Very good morning to all. I welcome all the participants for the online 1 week AICTE sponsored ATAL FDP on Advances in Construction Technique, 3rd to 7th January 2022. I welcome today's speakers, Dr. Mirnal Pal, Principal Scientist, CSR, Kolkata, Dr. Bharti Ganesh, Professor, NMIT Bangalore. Also welcome ma'am. Also
Right, thank
welcome
you.
Principal Dr. Atul Aire sir, and also welcome Dr. Anand Desai, Head of the Department, and the FDP Coordinator, Dr. Asif Iqbal Momin. Welcome you, sir. So I request Dr. Atul Aire sir to address the participant.
Yeah, very good morning, and
Very good.
wishing you the very, very happy and prosperous new year ahead. On behalf of Bijapur Lingayat District Education Association, I welcome all the participants, delegates, my faculty member, and above all, my fellow session speakers. I first of all welcome Dr. Minal Pal, a senior principal consultant, CSI Kolkata, and Dr. Bharti Ganesh, professor of NMIT Bangalore. Welcome, ma'am. Welcome, sir.
Thank you, sir.
Yeah, thank you very much, and wish you happy new year, ma'am.
Thank you.
Both of
Wish
you,
the same also.
thank you very much, and hope everything is fine at Bangalore and Kolkata, and hope this particular pandemic is not going to affect us a lot, and hope to continue such kind of ATAL FDP henceforth also. So again, heartily welcome to all my delegates and the participants for 1 week online AICTE sponsored ATAL FDP on advances in construction techniques during 3rd of January to the 7th of January 2022. Like as you said that like the BLD association is 111 years old association serving in the Bijapur and the Bagalkot districts of Karnataka, and more than 100 institutions starting from your nursery, KG, PG to almost a doctorate, and now we have a postdoctoral programs. We have BLD's Vachana Pitamaha Dr. P.G. Halkatti College of Engineering and Technology, which was established in 1980 and serving excellent quality education in the field of engineering, management, architecture, MBA, MCA, and a diploma, ITI. So we have a big technical campus of around almost 30 acres and catering to the needs of almost more than 10,000 students, and for them almost more than 5,000 faculty members and the non-teaching members serving on behalf of BLD Association. Bijapur, it's a small town which is located in a North Karnataka part of India, and basically famous for the horticulture, and obviously with the developing sectors in industry and the infrastructures and the road infrastructure especially. And we are like in a Bijapur, we are developing, and soon we'll have a international airport at a Bijapur also. A founder, a president of this institution, and current president, Dr. Ambi Patil. He was a former home minister and the former water resource minister for Karnataka government. He is the pioneer person to develop PLD's engineering college. Last 15 years back, Bijapur didn't have any kind of a water, but since Dr. Ambi Patil and his visionary, he's basically the visionary and having a dynamic leadership in the field of water resource. He's basically the doctorate in a civil engineering, and because of this water crisis, he brought the water from the Almaty straight away 60 kilometers from the Almaty Dam. And now the Bijapur is having a plenty of water 24/7 and 365 days, thanks to him. And we are very honored and glad to have such a wonderful personality like our Honorable President, Sir Dr. Ambi Patil. Along with him, Shri Rahul Patil is known as a Basangoda M. Patil. He is a young director, always striving hard to and get the excellence from the BLD's College of Engineering, and he's always behind us and to organize such kind of the ATAL FDPs or many more. And because of those particular efforts by the Mr. Rahul Patil, now we today very stand at a very good position. And just now on a first day of this particular month, on a very first day, we secured the promising band in a this area ranking by the MHRD and the AICTE. We are very happy. And in last month also, we did receive Institution Innovation Council's 3.5 star rating out of 4. And that is also incredible achievement. And before that also, Karnataka Science and Technology Council, ASCCT, they awarded us a best performing college of the year 2021. This was never achieved before by the BLD College of Engineering. But now today we are very happy with last 40 years of this particular saga of engineering college. We are leading the team. We are going ahead. We are connecting globally. We are doing all kinds of our programs, internationalization, and we are very happy that my students or the Bijapur students or the around people, they are getting benefited with the vision of Dr. M.B. Patil and Mr. Rahul Patil. We are very happy, and I must congratulate Dr. M.N. Desai, HOD of the Civil Engineering Department, to organize such a wonderful online AICTE sponsored ATAL FDP, Advances in Construction Techniques. Both of my session speakers must know that with this particular construction techniques, we wanted to have a one visit to the Dubai Expo this year. But and obviously the registration were very high, but because of again Omicron and the Delta variants, we have to stop those particular activity. But soon, to see this particular beautiful architecture and the construction kind of the techniques available very near to India, that is 3 hours just flight to Dubai and the UAE. That is a wonderful what you can say the experience. My students and the most of my faculty members should get it. So again, with the new zeal and the what is the promising future, we wanted to organize such programs, international programs in Russia. Now we have planned. Dubai, of course, is there, and we have a next is the Slovakia. So there are many like in a lineup, and definitely we will see that my students, especially from the civil architecture, should get hands-on training, hands-on learning experiences in the construction techniques, which is widely available. Obviously, India do have a promising in the infrastructure development and the prospects, but I know that there are two best session speakers available from the CSI and NMIT Bangalore. They are going to have these wonderful sessions on basics of nanoscience and nanotechnology, trends of technology of modernization of the construction engineering. This is a promising field which will be explained by the Dr. Minal Pal and Dr. Bharti Ganesh, respectively. So once again, I welcome both session speaker, and obviously you're most welcome to the wonderful, what you say, our campus in Bijapur. You're most welcome, both of you, session speakers, and my delegates and the participants. They are lucky to have such session speakers, and obviously they will get hands-on, what you say, the learning experiences from these two session speakers. So once again, the Department of the Faculty Civil Engineering at the BLD Engineering College is been congratulated for your wholehearted support for this ATAL FDP. And thanks, Coordinator Dr. Asif Mobin, FDP Coordinator on behalf of AICTE. So obviously, we gonna see the beautiful, bright future 2022 and ahead, and we can see the wonderful miracles in the construction techniques. Thank you very much, and have a nice day.
Thank you, sir. Thank you very much.
Yeah,
Now I request Dr. Asif Iqbal Momin to brief about the ATAL FDP as well as introduce the today's session's speaker, Dr. Minal Pal. Sir, over to you.
Thank you, Naeem. Thank you, Principal Sir. I welcome all the participants to this AICTE sponsored ATAL FDP on Advances in Construction Techniques. I, on behalf of Management and Principal BLDA Association, thank all the participants for registering to this FDP. We have total 87 participants all over India, and they are from the AICTE approved engineering colleges as well as polytechnic colleges. Few participants are also there from industries as well as from the government sectors. I thank AICTE ATAL for sponsoring this program. The main objective of this FDP is to learn about recent advances in construction techniques in different fields of construction and to employ innovative building materials and techniques. With this, I heartily welcome you all. Now, I am honored to introduce today's resource person for the first session, Dr. Mrinal Pal. Dr. Mrinal Pal, who is a senior principal scientist at CSIR, Central Glass and Ceramic Research Institute, Kolkata. Sir has completed PhD in science from IACS Jadavpur University. His professional experience are, he has completed postdoctoral fellow from University of Roma, Italy, postdoctoral fellow from Japan. He has joined as principal Sir is now serving as a senior principal scientist at CSIR CGCRI from 2016. Sir has received more than 15 awards and recognition. To name few, MRSI Medal in 2016, STA Fellowship of Government of Japan, CSIR MRSI Life Member, IACS Life Member, EMSI Life Member, and many more. Sir has published more than 100 plus research papers in SCI journals. Sir has presented 10 plus keynotes and invited talks in workshops and conferences. Sir has completed 9 research projects and 3 are in progress. Sir has supervised and completed 7 PhD students and 2 are perceiving. We are lucky to have you, sir. I welcome you with this. Now I request Dr. Mrinal Pal to start his session.
Thank you, Asif sir. Dr. Mrinal Pal sir, I'll make you as a presenter. We'll check the presentation as well as the audio and video so that we can go with this.
I am audible to you all?
Yes, sir.
Yes. Okay. Let me share my presentation and please check whether it is visible or not at your end. Is it coming properly?
Yes, sir. Yes, sir.
So audio and video, there is no issue.
Perfect. Perfect, sir. No issue.
So can I start now?
Yes, sir.
Okay. Respected dignitaries, professors, my dear colleagues, and also my dear students. So this is a very good opportunity, and because just we have crossed New Year, so a very warm welcome to this session and very good morning to all of you. At the outset, I must thank the organizer for giving me this opportunity to say a few words about the nanoscience and nanotechnology before you all. I am Mrinal Pal, Senior Principal Scientist from CGCRI Kolkata. It's a CSIR institute. And I am working on nanoscience and nanomaterials and nanotechnology for more than 30 years. And my activities spread over like catalysis, gas sensing, magnetic nanoparticles, dye degradation, and so many things, nano semiconductors. And also recently I have started some work on white LED. So these are my area of activity, but today, as suggested by the organizers, I will give you a very basic lecture on nanoscience and nanotechnology. Basically, it will be a very informative kind of things, and it will cover from the very beginning of nano, means what is nano, why they are so much importance, how nanomaterials is prepared, what is the background of nano, I mean, what is the history of nanomaterials, what are the applications areas, what are the challenges till date in the area of nanoscience and nanotechnology. Means I will give you a overall overview in the area of nanoscience and nanotechnology, and I will not going to give you anything regarding our research activities. If somebody is interested, he or she can consult my website, it is there. And if somebody is interested on some special specific activities which is going on in our lab or in our group, then also he or she may contact with me, because my email address is given there at the title slide. So that is basically the outline of my talk. And so as I promised, I will start from the very beginning, because I think this is the first lecture of this faculty development program, and also first lecture on nanoscience and nanotechnology. So it will be very basic type, and it's meant for the beginners. So those who are expert in this area, please excuse me. But for them, message is that yes, we are working in the area of nanoscience and nanotechnology for more than 30 years. So if you have any interest on some of our work, you can contact with me. Okay, let's start with the brief of this nanoscience and nanotechnology. So what exactly nano means? Actually, nano is a Greek word, and it means dwarf. And as you know, nano is 10 to the power minus 9 meter. The approximate area of hydrogen atom is 1 angstrom like. So if you arrange around 10 number of hydrogen atoms one by one, then it will cover 1 nanometer. And the most important thing is with our open eye, unaided eye, we can see things which are bigger than 10,000 nanometers. So you can understand which we cannot see below 10,000 nanometer, we cannot see, but we are working in an area where materials are in the area size of 5 to 10 nanometer, 20 nanometers, or maximum 50 nanometers. So you can understand that very special equipment is required for seeing that things and for manipulate that things in different places. So let me explain you the definition of nanomaterials. Actually, the conventional definition of nanomaterials is it's a material whose one dimension, as you know that every material has 3 dimensions. So at least one dimension should be less than 100 nanometer. That dimension could be particle size, that dimension could be layer thickness, that dimension could be length of the material, anything. But by definition, one dimension should be less than 100 nanometer. But precisely it is the size where actually quantum size effect prevails. What is that? That is that if you go for very smaller size, that particles will be from quantum mechanics, I can say that that particle will be confined in a box, and it will give some special effect which is called quantum size effect. So it is the size of material where we can observe that kind of quantum size effect. That is, in true sense, will be the nanomaterial. And if we look at the little bit of physics which is there in the right hand side, the size will be of the order of d by wavelength, which is few angstrom. So it is basically very, very small. And why we are doing? Because all the properties of same material will change drastically if we go to the nanomaterial dimension. So for example, if you have some material in bulk, its property is completely different in nano shape. Okay, nano shape or nano dimension. So definition wise, nanoscience is the study of fundamental principle of molecules or structure which are between 1 to 100 nanometers, and nanotechnology is application of that nanomaterial in devices. So that is nanotechnology. Now, if you look at this chart, you can see that where nano belongs. So this is the resolution kind of things. as I told earlier, that we can see maximum 10,000 nanometer and not be below that with our open eye. And if we are interested to see something below that size, then we have to have some special instrument. We call them microscope. So from few micron to sub-micron range, it is possible to see that materials by using some ordinary light microscope, optical microscope, which we call optical microscope. But from sub-micron to nano range, that is not, because they are very, very small, that is not possible by that kind of optical microscope or light microscope. And for that, you have to have some special microscope, which we call electron microscope. Means here electron is the probe, and as you know, electron wavelength is very, very small. It's the order of angstrom, whereas the light wavelength is much higher. For example, visible light range is from 400 to 800 nanometer, as you know. So we are using a very, very small probing stuff, which is electron, whose wavelength is of the order of angstrom. By that only it is possible to see the nanomaterials. What kind of materials these are? They are basically atoms, small molecule, proteins, lipid, some virus, like that. They are basically nanomaterials, and for that you have to have this kind of special electron microscope. Now, if we look at the history of nanomaterials, I can say that yes, there was nanomaterials from the very beginning of human civilization. From the left hand side, you can see in ancient Roman era, there was some kind of, they made some kind of calf, which we call Lycurgus calf. That is a special kind of calf, and it can give different color if you look at from different angle. I will give you details of this in my next slide, but this calf is still there in British Museum at London. These are the, we call it stained glass. You have definitely you have seen that if you go to the old churches, there they use some kind of colored glass. Please remember that colored glass is not just by making some, coating some color on that glasses. They are by basic instinct, they are color because of their composition, because of their internal materials. They are colored. That is why they are called stained glass, and that has been preparing from medieval era, like 500 to 1450 AD. And also in the era of Renaissance, there was also some this kind of decorative item, which are also example of nanomaterials. So that time people used very small particle, actually nanoparticles of copper and silver, to making this kind of lustering effect of on the these devices or the showpieces. So these are the historical things about nanomaterials. That means, what I mean to say, that nanomaterials was there from the very beginning of human civilization, and it is playing an important role. But the thing is, as for example, this Lycurgus calf, which I promised you that I will discuss a little bit more, you can see it's the same glass. In left hand side, this is this color is red, then it is in between red and green, and this one is green. Actually, depending upon from which side light is coming, I mean, if you see it on transmission mode, then color is red, and if you see it on reflection mode, then color is green. That means the this is a metallic structure inside that glass made cup is there, and that cup made by glass, that is absorbing some light, and that is why it is different color in transmission mode. But while you are seeing in reflecting mode, it is green, because it is not absorbing that much of light. And if light is absorbed, you can understand some wavelength will be missing, and so different color will come. So that is the Lycurgus calf, which is there still now in British Museum at London. Now the thing is, actually nanomaterial, not only in the this kind of calf or in museum you are seeing this nanomaterial. In fact, nanomaterial is made by Mother Nature, and it is very much there in human body also, starting from 14 DNA, antibody, virus, RBC. that is there. So various kind of very, very small particles are there in our body, which are prepared by created by mother nature, and that was there from the very beginning of our life. So now the question is then, what's new in nano, and why we are so much interested on nano, and why nano is the buzzword of the town or talk of the town. The point is, earlier the nanomaterials which I have discussed in the history of nanomaterials, or the nanomaterials which are there in our body, we cannot control their growth. We cannot manipulate them. But now with the advent of science and technology, we are able to develop a lot of sophisticated devices by which we can really manipulate these nanoparticles. We can create nanoparticles, we can create their, make their different morphology, make their different size, and we can manipulate their position also. So by doing all those things, we can get the benefit of nanomaterials for our benefit. So that is the new thing. As devices is there, as sophisticated things, instruments are there, now we can play with these nanomaterials, and we can use that nanomaterials in nanotechnology for the benefit of human beings. So modern nanoscience has started from 1959, actually, when famous physicist, basically Richard Feynman, he said, which is a very, very important quote, that is, there is plenty of room at the bottom. That means here bottom means he wanted to mention that if you go to the molecular size, if we go to the atomic size, then there are many things to do. Actually, what happens during that period, scientists, particularly physicists, was in a conception that there is nothing to do more for the physicist. And it was that kind of time when physicists was thinking what they will do in future. So at that period of time, Professor Richard Feynman, he mentioned that there is plenty of room at the bottom. That means during that period also, scientists were not that much concerned about the very, very small things like atom, molecule-like things. So he said, he predicted that if we consider all those small things, then there are so many things to do and so many new things can be created. So that was the beginning of nanomaterials. And in 1974, Professor Taniguchi, Norio Taniguchi, Japanese professor, he first used the term of nano. Before that, there was no literature available where nano term was there. And in 1985, basically, IBM has developed this STM, scanning tunneling microscope, which was a kind of revolutionary discovery, and using that devices, IBM could make a lot of things. And you can see this IBM logo, which is made by using 35 individual xenon atoms. So just by manipulating their position, they are able to create this IBM logo of that company. And since then, between 1990 to 2000, that period, first generation of application of nanomaterials has already came to market. And then the important discovery in 2004, which is this, what I say, this is this graphene, and because of that, they have they have received the Nobel Prize in 2010. And then after into 2016, so a group of chemists, they have first developed this nanoscale machine. You can see this one, it's a kind of car-like, they called it nano car. And that is also basically very much important for doing research in the area of molecular things or atomic things. And they also got Nobel Prize in 2014. After the discovery of these things, maybe 2016, I forget the exact year. So this is the basically evolution of nanoscience and nanotechnology. And now nano has come across a lot of areas. And now the question is, why nano is so much important? Important because, as I mentioned you, if we go to nanometer scale, all the properties changes, particularly this mechanical property, magnetic property, optical property, conducting property. electrical property, everything changes in comparison with their bulk things. Not only that, the change of that properties can be used for getting much improved devices. And also most important thing is in nanometer scale, it is possible to generate some new properties also. I will highlight this point particularly, some new properties. So these are the beauty of nanoscience and nanotechnology. And if we look at the application of nanoscience and nanotechnology, you can see that it is now covering almost all the areas of our science and technology, starting from agriculture to medicine to pharmaceutical to textile to construction engineering to energy to environment. So it is everywhere. It has make a huge dent in particular in this medical line and also in electronics. I will highlight some of the achievement of this in this area in later on of my lecture. So nano is covering everywhere. So some important properties I should say what is changing basically in comparison with their bulk counterpart, like if we consider a ferromagnetic or ferrimagnetic material in bulk state, it will be a paramagnetic, rather more precisely super paramagnetic material in nano stage. Even a paramagnetic material can go to ferromagnetic state in nanocrystalline state. And metal can, this is also very interesting, metal can behave like semiconductor in nanomaterial dimension, nano dimension. Ductile materials can show superplasticity in nano dimension. And this most bottom line, you see that gold becomes ordinary metal and loses its signs, means gold is very lustrous, and because of this luster we use it as a jewelry and also in medical. And I will show you that if we go to nanometer dimension of gold particle, it can really loses its sign and it can create different color. So for example, there is a you see this one is the real gold bar, that is the real gold color. But now there are available meso gold kind of things, which is a colloidal solution of gold nanoparticles in some particular solvent, and you see color is something like pink. That is also gold based. And you look at this color, so almost all the colors you can create from gold. If you decrease the size from bigger is this color and this lower is something like red. And these are more specific. For 100 nanometer gold, the color is like purple pink. For 20 nanometers gold, it is like red. And for 1 nanometer gold particle, it is something brownish yellows. So you can understand the gold, which is golden color, that's golden color comes from this gold only, that completely vanishes in nanometer dimension. And not only that, we can create different color if we control the size of gold particle. So this is very important information regarding nanomaterials. Now the questions may come that why this kind of drastic change is happening, why this kind of new phenomenon is appearing in nano dimension. So let me tell you, there are 4 major reasons for what the changes in properties is occurring. One is this one we call surface to volume ratio. I will give you a little bit more about all those things. This one is number of surface atoms. This one is band gap of material. You know that semiconductor and insulator has a band gap, though metal doesn't have. So band gap is also one important factor. And this one particularly for magnetic material, because as you know, magnetic material consists of a lot of domains. So if you control the domain size, also decrease the domain size, then magnetic properties can also change. So let me explain a little bit more elaborate way on these properties. So regarding the surface to volume ratio, you see, if you consider 1 nanometer cube, that cube has 6 surfaces, so area will be 6 nanometer square, 6 meter square. Now, if you make half of these in every space, then basically it will generate 8 cube. So here area will be 6 into half into 8, so it is 12 meter square. What I mean to say that your volume, total volume will remain same, but as you are making smaller size, your area is increasing. That's why surface to volume ratio will increase. On the similar way, if you make 1/3 of all those things, then there will be 27 pieces and area will be 18 meters square, though the volume are remaining same. That means surface to volume will increase enormously if we go to nanometer dimension, and that is one important factor why different properties is changing in nanometer scale, because this surface to volume ratio controls a lot of surface properties, and like starting from mechanical to thermal conductivity, everything, and some chemical reactions also, chemical properties also depends on this surface to volume ratio. So that is one important factor. Another one is this band gap of material. You know that semiconductor and insulator has some band gap. Semiconductor band gap is smaller and insulator band gap is higher, whereas metal does not have any band gap. So if you look at this picture, this top left hand side picture, this one is the smallest size, means it is of the order of few atoms only. In that case, if you look at the band structure, it will not be band. It will be basically collections of few atomic layers. And if you make the size of this particle bigger and bigger and bigger, then basically all the layers will collapse and it will make the band. So that is the basic conception of band theory. So that is basically for bulk properties, bulk particle, and you can understand this is a kind of semiconducting material where this is the band gap and this is conduction band and this is valence band. So if we go into smaller size, so same thing will happen. So the band will disappear and it will be like atomic level kind of things, and band gap will increase. So that basically controls all the properties, particularly conductivity properties, optical properties of material, and that's why in smaller dimension, in nanometer dimension, properties, optical properties and electrical properties changes. Here I have given a very important example which is very popular also. This is basically nothing but CDS, cadmium sulfide nanoparticles of different size. This one is the smallest size and this one is the biggest size. All of them are in nanometer dimension. For example, if you say if this one is 5 nanometer, maybe this one is 20 nanometer. But important point is all of them are cadmium's, pure cadmium sulfide nanometer, and because of their size only, we are getting different color starting from blue through green, yellow to red. Almost all the visible color we can achieve from same CDS, cadmium sulfide, just by changing their size in nanometer scale. Now comes to surface, number of surface atom. You look at this graph. I am audible, na? Hello? Hello?
Yes, sir. Yes, sir.
And it's everything is visible, na?
Yes, sir. Everything is fine, sir.
Okay, okay. Thank you. So look at this graph. This graph, x-axis is the dimension or size, you can say size of particle, and y-axis is number of surface atom. You please note this is number of surface atom. So if we start from this one, means bigger size, you see the number of atom is very, very less. But when we are decreasing the size, number of surface atom is increasing, and it increases enormously when the dimension is of the order of 1 nanometer. It is huge. And if we make some ordinary calculation, we can say that for a sphere of 12.5 nanometer, only 10% atom will come to the surface. But for same material, if the sphere radius changes, like it changed to 5 nanometer dimension, then 25% of the atoms will come to the surface. So as you go on decreasing the size, the number of atoms in the surface will be higher and higher. So my point is that if number of atoms in the surface increases, then again surface property will change in nanometer dimension in comparison with its bulk counterpart. And this one related to particularly for magnetic material, as you know, ferro or ferrimagnetic material conventionally, which are magnetic material, they contains lot of domain. You see this picture, different things are different domains are there, and if you go on decreasing size, that domain size will decrease, and ultimately it will come to this single domain size, where coercivity, which is a important property for magnetic material, will maximum. And then if you go down below this single domain, then it will lose its coercivity. Coercivity will be 0, we mean to say that it will be a paramagnetic material, because for paramagnetic material there is no coercivity. Means if you increase the magnetic field, then magnetic moment will increase. If you make it zero, means if you stop the applied magnetic field, then it will not show any magnetic property. There will be nothing inside it. That is basically paramagnetic material. So you are starting from ferromagnetic material. Just by decreasing size, you are going to paramagnetic. That's why I have mentioned that time that in nanometer dimension, ferromagnetic particle can behave like paramagnetic particle. So this is another important reason why the magnetic properties of nanomaterials changes in nano dimension. Now I will highlight about the type of nanomaterials. If you look into the literature, then you will find that there are various types of nanomaterials, starting from 0 dimension to 1 dimension to 2 dimension to 3 dimension. As you know, a bulk material has 3 dimensions, so that is bulk. So you look at this left hand side figure, this we call 0 dimensional material. What does it really mean? It really means they are very, very small, maybe 1 nanometer, 2 nanometer of dimension. And in that dimension, we call them 0 dimensional because we consider that they are really very, very small and they does not have any dimension. And we call them also as quantum dot because they are very, very small, and in this case really quantum size effect prevail. All in this case for 0 dimensional material, all 3 dimensions, all 3 directions are restricted or constrained. Now in comparison with that quantum dot or very small particle or 0 dimensional particle, if we think of 1 dimensional particle, what is 1 dimensional particle? 1 dimensional is basically it's 2 dimension. Among the 3 dimension, 2 dimension will be very, very restricted. Only 1 dimension will be open up. That means it is kind of nanotube or nano wire, where length of the wire or length of the tube can be anything, but the other 2 dimension like y dimension and g dimension, they will remain in nanometer dimension. So these kind of materials like CNT, very popularly known CNT, carbon nanotube, they are 1 dimensional material. Now come to 2 dimensional material. What is that? 2 dimensional material means only 1 dimension is constant or restricted and other 2 dimension you can increase. So this is also kind of nanomaterial because the dimension which is constant, that will be in nanometer dimension. Example is very thin film, or you can say nowadays this is 2D material. You have heard that 2D material, 2 dimensional material. So like this graphene and MOS2, they are important 2D material. Here basically X and Y axis you can play with that. They have no restriction on this X and Y axis, but G direction means thickness of the film, that is very, very restricted. It can be monolayer or few layers. That means they will be this dimension G direction, that will be again in nanometer dimension. So this is 2 dimensional material, and here this picture is bulk material. Basically it is 3 dimensional material. It has all 3 dimensions are free. You can increase any dimension. So starting from 0 dimensional means quantum dot to 1 dimensional means nanotube or nanowire to 2 dimensional. This is basically 2D material, means very, very thin film starting from graphene to MOS2, like that. It is bulk material. So these are the type of nanomaterials. Because of time constraint, I will not go into details because what I am going to cover in this lecture, if I discuss everything in detail, so it will be a 24 hours lecture like. But I have to complete it maybe within 1 hour or something like that. So I am very briefly showing you, but touching everything. Now coming to preparation of nanomaterials. Actually, while you are thinking about the preparation of nanomaterial, you have to consider some restrictions while preparing nanomaterials. Grossly, we can say there are 2 types of preparation technique. One is called bottom up, another is called top down. Top downs means you look at this picture, this is top down. Top downs means from top means bigger size to smaller size. So this is your bigger size, and you are just by controlling preparation parameter, you are going to smaller size. So this is nanomaterials. So this is top down approach. There are different methods like mechanical milling, etching, laser ablation, sputtering. These are kind of top-down method by which you can prepare nanomaterials from bulk. Again, on the other hand, which is bottom-up approach, they are from bottom, means from very smaller size, means it could be atomic scale. So from there, you can prepare nanomaterials. You look at this. So from bottom-up approach, here it is molecular or atomic level. So it will be little bit bigger, and ultimately you will end up with this nanoparticle. So this is also another kind of approach which is completely opposite than top-down approach. And by that approach also you can prepare nanomaterial. So in bottom-up approach, there are many processes like this spinning, sol-gel process, chemical process, then chemical reduction, molecular condensation. There are many processes by which one can prepare nanomaterial using this bottom-up approach. Now, the characterization part. Any material can be characterized using this kind of XRD, means X-ray diffraction pattern, differential thermal analysis, and transmission electron microscope, using that kind of things. But for nanomaterials, which are very, very small size, smaller in size, you have to have special instrument like this transmission electron microscope or AFM kind of things. So if you go on, if you look at this picture, if you go on the decreasing the feature size, then you have to decrease the probe size also. And in nanometer dimension, the most versatile and most important tool is transmission electron microscope. By using this electron microscope, this kind of electron microscope, you can really see the material in nanometer dimension. So there are various sophisticated tools for structural characterization and also composition characterization of nanomaterials, like same term as I mentioned. This is surface, this is scanning turning microscope, and also various kind of other techniques are there using some indirect way like Raman and invisible study. You can characterize the nanomaterials. So let me show you this, which is most important, as I told, for nanomaterial, like this TEM, transmission electron microscope. This is the TEM, transmission electron microscope. Here actually there is some electron gun where electron is produced, then using very high accelerating voltage of few hundred kilovolt, we can make them very energetic electron beam, and your material which we want to see will be here in this place. So electron beam will come at high speed into a material, and there is some screen. Using that screen, you can see the nanomaterial. There is screen. So this is a real picture from TEM, which is the spherical particles are very, very small. They are nanoparticle, and you can see they are almost what I say, monolithic, means they are monodispersed particle size is almost similar. Also, if you look at this pattern, here you can see here there are some parallel lines. Here also there are some parallel lines. Actually, if you have very high resolution transmission electron microscope, then only this kind of structure can be generated. And from this parallel line, just by making the measuring the distance between the parallel line, it is possible to characterize them, structurally characterize them. We can understand their plane. These are basically different plane of nanomaterial. If you know little bit about the crystal structure, there you will find that there are different plane, and their plane is indicated by some Miller indices. So all these are plane, and that Miller indices can be calculated using this kind of high resolution picture. So that is characterization of nanomaterials. And if you look at this chart, you see starting from physics to computer science to biology to chemistry, because of the advent of nanomaterials, from one place we can go to other dimension or other area very quickly. Like in chemistry now, it is carbon dots, which I have explained that nano material, zero dimensional material. So, they are very, very important for different kind of application. You see in computer science, when first computer was developed in the year around 1950, the dimension of that computer was a dimension of a room like. Then Apple first computer was this one, which is also placed in a bigger table. So size was that much big. Now in 2018, you can see that this is a very, very thin laptop. And all these achievement has been made possible because of this nanoscience and nanotechnology. See, in a similar way, because of these various sophisticated tools, now we can see 1 nanometer also, like the size of glucose atoms or glucose molecules you can see. In the area of physics also, you can see that earlier we used to only XRD, X-ray diffraction pattern for characterization. Now it is TEM, XPS and AFM also, atomic force microscopy, by which we can characterize nanomaterials. Now, I will say a little bit about the application of nanomaterials. You look at the pictures, all these are application of nanomaterials, which we call first generation application of nanomaterials. First generation because it's not purely nano, but we are taking help from nanomaterials. For example, your AC and washing machine, in their filter, they use some kind of coating which is made of nanomaterials, and because of that they can generate some microbial, antimicrobial activities, and they can create some fragrance in your garments and in your room. These are some clothes, they are also using some nanomaterials as a coating because of the same antibacterial activities. These are paint, some US based famous paint company. They are using some nanoparticles for making their colloid, which will give more strength to paint and it will be more durable. This is some Mercedes car, S series car. Nowadays they are using this nanomaterial based paint, and by that, using that nanomaterial based paint, they make it almost scratch proof. And here this is different kind of LED, different color of LED from same material. Just by changing the dimension of the same material, it is possible to create different color in the same material, different color LED. So these are the first generation application of nanomaterials. Right now we are using all those things and they are available in the market. But in true sense, a complete device based on nanomaterial, that or nanomaterial based device, that is not really available in the market, but in near future that will be definitely available in the market. As I told you, nano has also huge application in the area of medical or pharmacy, starting from diagnostic to therapeutics to vaccines or regenerative medicine. Everywhere nano is playing important role. I will give you some example for biomedical, some different biomedical application, particularly for labeling purpose. Nowadays, nanomaterial is very much important because there are some tests like MRI kind of things where basically some fluorescent particle we use, which are rare at best, but because of these nanomaterials properties, now we can replace that kind of radioactive or rare earth materials with some simple inorganic material we can use for that this imaging purpose. But one thing everybody has to be careful that nanoparticles should be non-toxic, they should be chemically stable, otherwise they can create some anti-reaction in your body. So these are the applications which are already people are using in medical line. Nanomaterials is also nowadays started application on targeted drug delivery, particularly this is useful for tumor or cancer. As you can understand that if some person has some tumor or some cancer in a particular part of the body, nowadays the technique is that you have to use some ray on that area. Of course, that ray has also a lot of side effects, and also you have to use some chemotherapy which basically kills the cancerous cell, but as well as it kills the lot of normal cells also. Basically, so what I mean to say that chemotherapy has a huge side effect. It can affect all the parts of your body. And the first symbol is if somebody use chemotherapy, he will lose his hair and he will lose and his other parts of the bodies also will be affected. But using nanomaterials, if you try for this kind of targeted drug delivery, which is nowadays and people are using in developed country in US and UK, though in restricted manner, what they are doing, they are basically using some nanomaterial as a carrier, and some drug is attached with that nanoparticles, and just by injecting that medicine in the body, it goes into the body, and then by applying some magnetic field from the outside, they can control their movement to the particular this tumor site. Means the carriers are magnetic nanoparticles. So if you apply some magnetic field externally, it will attract the this nano magnetic particle which contains the drug also. So just by changing the magnetic field, the materials can come to the this tumor site, and here only it will release. So only drug will react with your cancerous cell, and it will does not hamper your other cells or other parts of your body. And another important point regarding this targeted drug delivery is that it will use very less amount of drug, because it is directly coming to the tumor and it is not affecting your whole body. It is not affected distributed in your whole body. So that is one important application of nanomaterials in medical line. Another important use of nanomaterials, particularly magnetic nanoparticles in medical line, again it is magnetic hypothermia. What exactly it do? Again here, some magnetic nanoparticles, it does not need any drug also, is injected in the body in the particular position where there is tumor or cancer. Just by kind of injection needle, it is injected particularly at that point. So as they are magnetic particle, if we apply some magnetic field from outside, and if the magnetic field is alternating magnetic field, then with the change of field direction or with the change of frequency of that magnetic material which is injected in your body, they will also flip-flop. And as the frequency of this applied field is very high, so their motion will be very high, so the flip-flop will be very rapid. And by doing that kind of motion, some locally temperature will be generated, and that temperature can generate up to 42 degrees centigrade, because our normal cell can resist up to 42 degrees centigrade, but cancerous cell can die with that high temperature. So by using this kind of magnetic hypothermia using nanomaterials, it is possible to destroy the cancerous cell without hampering any normal cell. That is also still now in R&D stage, but maybe in near future it will come to markets. And then in that case, using this targeted drug delivery and also magnetic hypothermia, it will be very easy to treat cancer patient. There are another application of nanomaterials also, like this is Nano Generator. As you know, generator is nothing but a device or machine which converts mechanical energy, or you can say vibrational energy, into electrical energy. So here also some mechanical energy is converted to electrical energy just by using some kind of this nano generator. Their dimension is very small. They are really in nanometer dimension, and that can be used for typical kind of smaller electronic gadgets, particularly wearable gadgets, and also even for your phone, where you are not getting electricity. Just by using your motion of your body, you can charge your phone just by this kind of nano generator. Also, these are very much useful for very smaller kind of wearable devices, including the pacemaker and other things. So that is another application of nanomaterials. There are some devices which called, though this is in R&D stage, which called Nano Robot. This is nothing but a machine. Dimension is rather you can say robot dimension is nanometer dimension, and it can really works in nanometer range, starting from checking your DNA, repairing your DNA, and repairing your coronary artery blockage, and everything is possible using this kind of nano robots. This is also still now in R&D stage, so we can hope that in near future a lot of nanomaterial based devices will come into the market, which will particularly will be very much useful for medical purpose. And if we think about this electronics area, as I mentioned earlier that I will touch every area. In electronics, nanomaterial has already brings a sea change. I must say in sea change. You know that there are in semiconductor there are transistor and there are chips. Few days back, actually, if you listen to our Prime Minister lecture, their Prime Minister has mentioned that he has assigned huge amount of money for the semiconductor based chip, because as you know, till date there are no chip manufacturing company in India, and because of that lot of other application of these chip based devices are hampering. Particularly our automobile section is what I say, they are suffering huge. So that government is encouraging, government has allotted lot of monies for making this kind of chip industry in our country. What is that? Basically, a chip is a very small gadget which contains lot of transistors. In modern days, now the chip we call it 27 nanometer chip, means it is possible to use a chip dimension of the around 27 nanometer. But IBM has already developed 9 nanometer size, so they have made much smaller, means size will be much smaller, but you will get the same or higher performance from that chip. And also IBM is claiming that just by using carbon nanotubes, they have achieved 2 nanometer chip, which can contains more than 50 billion transistors. You can understand that how nanomaterials is really changing our particularly this electronics industry. So electronics industry in future, our all the electronic gadgets will be again much more smaller in size, and they will be very much compact device. Everything will be very much compact, and everything will be more powerful. So as I have almost covering everything, so as your this faculty development program is basically in the area of construction, and it is organized, as I understood, it is organized by civil engineering division. Though I am not an engineer, I am basically a physicist. So I will touch upon few slides on this area where in the area of construction engineering, and I will just try to emphasize that yes, in construction engineering also nanomaterials are playing huge role, and in future they will change a lot of things in construction engineering areas also. So application of nanomaterials in construction engineering, here basically one can use nanomaterials in concrete, in steel, in wood, glass, coating, and even in photovoltaic. Means all these are basically the part of this construction engineering, and everywhere you can get the benefit of nanomaterial. I will give you 1-2 example in this area. For example, nowadays the cement which is used by construction companies, that cements are basically if you look at the size of that cement particle, they will be of micron order, particularly 10 to 20 microns like that. But if it is possible, and now cement companies are thinking about that, if it is possible to make cements of nanometer dimension, it is already in laboratory level, it is proven that the strength of the cement will be much more higher. So that is one example of nano. Also, you can mix this carbon nanotube, nanosilica, carboxylate kind of material in very smaller amount in construction material, and by virtue of that, you can really improve the mechanical performance, bulk density, durability, and sustainability of this concrete. So these are example. For example, if you add 1%, you look at this 1% of it's a very small amount, really 1% of CNT in concrete, then it is so it has been observed that it can improve the compressive and flexural strength very much. The data is given here. Also, it is observed that if iron oxide nanoparticles, which is hematite in form, it is used in very less amount in concrete, it again can increase the strength. So all these are in R&D stage, and people are now cement companies and company those who are in construction areas, they are now thinking of using this benefit of the nanomaterials. Even in case of steel, which is one major component for construction engineering, you know that fatigue is an important factor for steel, and that fatigue basically comes because of the stress, and after that fatigue, basically there will be some fatigue failure. So it is already proven that if some nanoparticle, particularly nano copper particle, is used in steel, then it can make the surface much more smooth, and it can really restrict the appearance of fatigue just by checking the appearance of stress. So that is one important use of nanomaterials in steel industry. Yes, in case of glass also, as you know, glass is another important composition of modern building. We use lot of glass for decorative purpose as well as for the separating purpose in building. If we use a particular kind of glass coated with some material, particularly zinc oxide or tin oxide, then it is possible to control the internal environment and temperature of the building just by using this kind of glasses. And also I must mention, if you use some this kind of special coating, that glasses will be self-cleaning glasses. That means you don't need to clean the glasses every day. It will automatically clean just by virtue of nanoparticles. So these are the promising areas of construction engineering, which is basically useful just by mixing some nanoparticles in this area. So one can get idea of these benefits of nanoparticles in construction engineering. I'll stop just by showing this slide. I must highlight that yes, it is nanomaterial is also playing important role in fight against COVID-19 because it is the delivery of this mRNA-based vaccine, which is Pfizer vaccine and the Moderna vaccine, their delivery is also based on some nanomaterial, and it has been found that they are encapsulated in positively charged lipid nanoparticles. So nano is playing important role here also, and even scientists are proposing that just by using some gold nanoparticle in future, it is possible to detect this kind of coronavirus or other viruses just by naked eye, just by change of color, just by change of position. It is possible to detect the virus just by seeing all those things. So there is one very important publication in 2021 in Nano Medicine Journal. If somebody is interested, he or she can consult this reference. My point to show you that yes, nano is everywhere. Even in COVID-19 also nano is playing an important role. So I have come to the end of my lecture. I must say that nano has a lot of advantage which I have mentioned throughout my lecture. I have demonstrated lot of application of nanomaterial where we can get the benefit of nanoparticles. But I should say that there are some disadvantages of nanomaterials also. A disadvantage means it can pollute the environment. It can even hamper our body system also, nervous system also, if it is percolate through our brain memory. So one has to be very careful when using this kind of nanomaterials. Otherwise, it is very good. So special precaution is needed when you are preparing nanomaterials in your laboratory or in your industry. You have to be careful that you are not polluting our environment, or also you are not toxicating your body also. So that kind of precautions like mask, like apron and all those things, gloves, everything you have to use while you are preparing nanomaterials in laboratory or industry. So I must say that a pessimist see the difficulty in every opportunity, but as I am a scientist working in the area of nanoscience more than 30 years, I am an optimist, and an optimist see the opportunity in every difficulties. I must thank my group member, my students, those who are helping me in doing nano research in nanomaterials. Without them, it is not possible by me alone to do this kind of research, because they are the high-tech research area, I must say. And also I must thank CSR, DST, this kind of funding agency for financial support. Thank you very much.
Thank you very much, sir.
Yeah.
I request all the participants, if you have any question, you can ask the sir regarding any questions if you have any doubt.
Yes, I am available.
I request participants, if you have any question, please
You can unmute now.
And also you can ask any question in the chat box. You can unmute yourself and ask the question.
I guess there is no question or queries from participant. So,
Sir, I have a question. So,
yes.
in what all fields except I know, like our one of the HODs have done research on this nanotechnology, using nanotechnology on water treatment, and what
Yes.
else we can in the field of engineering, where else we can use it?
No, in fact, I did not cover all the areas because it's not possible in one lecture. But in general, I can say that in all the aspects or all the areas of science and technology, you can utilize nanomaterials everywhere.
Okay.
Starting from water to everywhere. For water purification also, I did not highlight. In our research institute, we have one group, those who are working on nanomaterials for water purification. And they have you know that the water filter, RO filter, which you used in your house for day-to-day use, they contains a lot of filters. And we are developing some kind of coating on that filter, that coatings are based on nanomaterial, which are giving more antibacterial effect, and it can also kill a lot of pathogens just by its chemical properties. So nanomaterial can be used. And also I did not highlight, in our institute we are working in some areas of nanomaterials which can contribute to our strategic sector, because that we are doing on confidential mode with DRDO. So that generally we don't present in this kind of common platform. But I must say that that is also possible. We are working for developing some kind of garments for this our army, which
Okay.
will be very tough. Even it is tougher than this, what I say, this making windows, glass windows also, to protect our armies. So that kind of work is going on, that are also based on nanomaterials. Also, DRDO is working on another garments which can control the temperature of this of our body just by using nanomaterial. Means they can change temperature much wider range. Because, as you know, because in Siachen kind of places, they need some hot kind of garments. Again, the same army use some kind of cooler garment when they are giving their duty in Rajasthan or Gujarat, the desert places. So DRDO is now developing some clothes based on nanomaterial. Means they are giving, its clothes is it's a textile product, you can understand, but some coating is given. What I mean to say, that they are using some nanoparticle based coating which will be useful to keep the temperature almost insulated like. So it has I must say it has application in all the areas, but everything is not right now available in the market, because earlier people used to work to know the nanomaterials, their fundamental things. Now almost fundamental things are known to scientists, and now scientists are working for their application. And I am pretty sure maybe within 5 to 10 years, lot of devices will come in the market which are really based on nanomaterials. The example which I have shown, they are first generation application of nanomaterials, but definitely within 5-10 years there will be a lot of other devices based on nanomaterials.
Okay. Sir, there is one more question from one of the participants, Dr.
Yeah.
N. Arunachala. And sir is asking that, is there any standard procedure to prepare a specimen from SEM and TEM?
Yes, yes. For ACM, actually, you don't need to take care of that kind of thing. If it is smaller particle or some kind of very thin coating, you can use ACM because it's a surface measuring technique. ACM, as you can understand, this is scanning probe electron microscopy, but this works in the surface only. It cannot go the depth of the material. But transmission electron microscope, as the name says, it works on transmission mode. Means this electron beam will transmit through your material. It has to travel through your material, and then only you will get the information about your material. So for that, you have to prepare a special kind of material. Actually, for TM study, some kind of copper-based grid is available from that chemical supplier like Mark and other chemical supplier. It is available, and using that grid, you have to drop 1 or 2 drop of solution on that grid. That solution contains the nanomaterial, and basically that solution will generate a very thin layer on that grid, and then you have to place the grid inside this TEM machine, which I have shown the device, and just by placing that material in the TEM machine, you can see the particles of nanomaterial. So for TEM, you have to be taken care for material preparation, and you have to have that kind of grid, otherwise it is very difficult.
Thank you, sir. There is one more question from Dr. Preeti A. Patel. Ma'am is asking, is agencies provide nanomaterials for nano concrete, or one has to create?
Pardon me, can you repeat, Anis?
Is agency provide nanomaterials for nano concrete?
Is
agencies, any agencies are providing nanomaterials to prepare concrete?
No, it's not agency or something like that. What I have highlighted, that if you mixed nanomaterial in your concrete materials, it could be cement, it could be glass, it could be wood, it could be paint, whatever may be. If you mix, means the maker of these companies, now there is no agency. For example, one famous glass company maker is that Plinklinton, US based company. Now they are using nanomaterial in their glass for giving this kind of properties. Like if you use that kind of glass based windows, then your temperature inside the room will be controlled. Or just by capturing the UV part, you can release the IR part of your light, and you can heat your room also, particularly for Europe and America, they need to heating. So that glass can be, so it is the company, those who are making the cement, those who are making the glass, they are doing their R&D based on nanomaterials to get the improved property on those devices.
Okay, thank you, sir. Thank you so much for giving the good information on nanomaterials and applications in all the fields. And I thank you, sir. Now I request our Dr. Naveen Desai, sir, to present the letter of appreciation.
Good afternoon, sir.
Yeah, good afternoon.
Good afternoon, sir. On behalf of BLD Management Principal and Department of Civil Engineering, I am very thankful to you for giving a wonderful lecture, sir, on this nanomaterial introduction. As a token of love, please accept this appreciation letter from us, sir, from the management.
Yeah, thank
Please,
you.
sir.
Yeah, thank you.
Thank you. Thank you so much.
Thank you for accepting our invitation and presenting this wonderful session on the nanotechnology. Hope this will be a basics for other participants, where the next application part on this nanoscience will be by Vibhiti Bhushan Das sir from NIT Surathkal. Hope this session, that's why we kept a session on nanoscience and nanotechnology basics, so that they can easily understand its application part taken up by the next coming resource person. Thank you.
Yes.
Thank you very much, sir.
Thank you so much, sir.
Yeah, thank you.
Participants, please be here with us.